Hi guys, today we're going to talk about acids and bases. You already know some things, and so we're just going to add a little bit of information to the knowledge you already have. So let's do a quick review of what an acid is and what a base is. So something is an acid if it has a hydrogen ion found in it, and usually those are found at the beginning of the formula, like versus the end. There are a couple exceptions, but generally H means acid. On the pH scale, you know that they have a low pH. They fall between 0 and 6. And if I tested it with litmus paper, an acid will turn this paper red. Now a base, on the other hand, has a hydroxide ion, OH-. Usually those are found at the end. Again, a couple of exceptions, but generally look for the OH, the hydroxide, at the end. They have a high pH, falling from 8 to 14, and they turn litmus paper blue, so very opposite of acid. So, here's the bad news. You need to memorize the list of acids and bases on your paper. So you need to know their names, you need to know their formulas, you need to know, are they strong acids or weak acids, or strong bases or weak bases. So this might be something you need to make flashcards for, you might need to practice this over and over. I really am serious, you gotta memorize it, I'm sorry. Okay, so let's go through this list so you got it. Okay, these are your strong acids. HCl is hydrochloric acid, H2SO4 is sulfuric acid, and HNO3 is nitric acid. And so there's kind of clues in there, right? Cl means chlorine, S means sulfur, and N means nitrogen. So the names mostly match the formulas, so it's not too far off, but you do need to remember all of the numbers and all of the letters and the names, and that these ones are strong. Now we also have some weak acids. There's CH3COOH. That's actually called acetic acid, which is another name for vinegar, like the kind that you eat. Okay. Other weak acids are anything that is an organic acid, a carboxylic acid, and you remember that you learned that is anything that has a COOH group attached to it. Even acetic acid falls in that group. There's the COO group right there. So anything with a COOH, carboxylic acid, you would classify as weak. Now let's talk about the bases. So our strong bases, sodium hydroxide and potassium hydroxide. Notice that they both have the hydroxide in them because of the OH at the end. That's the name for that. The weak bases are a little bit tricky. They're kind of exceptions to that rule. NaHCO3 is baking soda. Another name for that is sodium bicarbonate. Okay, and so notice it doesn't have the traditional OH that we're looking for, so it's an exception to that rule, but it still is a base. And same thing with ammonia. This is what we clean with, and it stinks really bad. It also doesn't really have the OH in its formula, but it is still a base, just on the weaker end. So that's the list of what you got to memorize. Okay. So when we name these acids and bases, you'll usually know that something is an acid because the ending of it will be something-ic acid, like hydrochloric acid, sulfuric acid, nitric acid, acetic acid, carboxylic acid. So that's how all of them are named, and that's going to be another clue to help you figure out, well, is that an acid or not? Bases will usually have a hydroxide at the end, which kind of follows the normal ionic naming rules where it's something and then OH, which we call hydroxide. If you have to figure out the formula, then you just crisscross. So sodium hydroxide is Na plus 1, OH minus 1, and I crisscross, and that's where we get NaOH from. So you should be able to do some of those general names and formulas. And here's why this matters. We can put all of this together into what's called neutralization. This is where you're creating a neutral solution by combining an acid and a base to make water and a salt. So basically the acid and the base cancel each other out. The products of that will always be water and salt. Salt just means anything ionic. It is not always the salt that you eat. There are hundreds and hundreds of salts because it's just anything that is ionic. So the general formula is you'll see acid plus base. These are your reactants. You always have to have water and some sort of salt as your products. So let's look at the couple examples given and see if we can identify those pieces. Remember, an acid is usually going to start with an H. So right here, this is the acid part of neutralization. NaOH ends in OH. That looks terrible. I'll write that neater. A base tends to end in OH because I see that this piece is my base. Okay? So notice in neutralization, when I put those pieces together, H and OH, I get this. HOH is just another way of writing H2O by combining those pieces of acids and bases. So here's the water that's formed, even though it's written HOH, and that means NaCl must be the ionic salt that was formed. So you try the next reaction. See if you can find the acid, the base, the water, and the salt in there. Alright, let's see how you did. This has an OH in it, which means it is the base. This starts with an H, meaning it is the acid. And over here, I have no idea what this is, but I see HOH over here. That's my water. And that means this other thing that I wasn't sure of must be the salt that's formed. So you just need to be able to identify a neutralization reaction by picking out all of the parts. So when I do neutralization, it helps me do something called a titration. So this is where we determine the concentration. Remember, concentration means molarity. And we're determining of the molarity of the acid or the base by neutralizing it. How much acid or base does it take to neutralize? And so what we do is in here we might have some acid. And up here this thing is called a Biuret and it's full of base. And so we slowly drip base down here until this acid becomes neutral. And by measuring how many little drops did I do, that helps me figure out, well, what was the molarity of this thing to begin with? And you know how to do this math already because it uses our molarity formula, M1V1 equals M2V2. So we're going to do a little practice with that and get it back in your head. So grab your calculator. M1V1 equals M2V2. Okay. Now when you do this, you kind of want to think as like, alright, one side is going to have all the acid stuff on it, and the other side will have all the base stuff on it. So let's see what they give me up here. Here's a number, here's a number, here's a number. It says, whoops, what is the molarity of the basic solution? So if I say, here's my base side, I don't know this new molarity. So that's where X is going to go. Okay? They do tell me that the basic solution volume is 30 milliliters. So that means the acid numbers that I have, the molarity is 0.250 and the volume is 26.4. So then I just have to solve and plug this in your calculator. And I get over here 6.6, solve for X. So you put that into your calculator. My calculator says 0.22. So if I look up here, everything else that they gave me had 3 sig figs. So in order to add a third sig fig here, I could put a 0 there and it's the same number. So my answer becomes 0.220. And I was looking for a molarity. The unit for molarity is the big M. Alright, let's try one more. And so let's do our formula again. M1V1 equals M2V2. Alright, what numbers do they give me here? There's one, there's one, there's one. Okay, so it says, what is the concentration of ammonia? Remember, ammonia is a base, okay? Concentration is another word for molarity. So once again, I don't know M2, so that's where X will go. Okay, let's see. Then I see ammonia again here, and it says that we have 25 milliliters of it. So that must be my V2 over here. These two numbers pertain to HCl, which is an acid. So I'll put those together on the M1 side. Alright, so I have 25X over here. Multiply these two numbers. And I get 29.441. Then I just have to solve for X. This cancels. This goes in your calculator. So X equals 1.17764. And just check out your sig figs. So I see 4 here, 2 here, 4 here. When you have the choice, go low. So I want to have 2 sig figs. The second sig fig is right here at this 1, but the 7 is going to bump it up. So my answer becomes 1.2. I was solving for concentration, and concentration, the unit is M for molarity. Alright, that's it. Let me know if you have any questions.